Good day, CBP students. We are now in our Chapter 5 on Binomial Theorem. For any positive integer n, a plus b quantity to the power of n is equal to n taken 0 at a time times a to the power of n plus n taken 1 at a time times a to the power of n minus 1 times b plus n taken 2 at a time times a to the power of n minus 2 times b squared plus up to n taken r at a time times a to the power of n minus r times b to the power of r. Then up to n taken n at a time times b to the power of n. In summation notation, we write a plus b quantity to the power of n is equal to the sum of n taken r at a time times a to the power of n minus r times b to the power of r from 0 up to n. The binomial expansion of a minus b quantity to the power of n is given by a minus b quantity to the power of n is equal to a plus negative b quantity to the power of n, which is equal to the sum of n taken r at a time times a to the power of n minus r times negative b to the power of r from 0 to n, which is also equal to the sum of negative 1 to the power of r times n given r at a time times a to the power of n minus r times b to the power of r from 0 up to n. Note that the terms in the expansion alternate in signs. So, this is our binomial theorem. So, ang kanis siya, tawag niya siya binomial coefficient. O, kana siya. N taken 0 at a time, ana n taken 1 at a time, na siya pagbasa. So, let us give examples later. That is atas atong remark. Factorials at binomial coefficients. We define n factorial, okay, this is read as n factorial as follows. So, ito siyang i-define as follows. This is 0 factorial, which is equal to 1. Then we have n factorial, which is equal to n times n minus 1 times n minus 2 up to 3 to 1 if n is a positive integer. Clearly, n factorial is equal to n times n minus 1 factorial, which is equal to n times n minus 1 times n minus 2 factorial. Pascal's rule also gives rise to Pascal's triangle. Okay, class, so this is the Pascal's triangle. So, sa itong naobserbahan, okay, one tanan diri na sa outside sa triangle. And then, ang 1, adan og 0, 1 lagi hapon diha. Then 1 plus 1 is 2. Diri pod 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And so on. So, mo na siya pattern sa ato ang Pascal's triangle. So, sa atong base sa triangle, we have this. 1 plus 7 is 8. 7 plus 21 is 28. And so on. So, mo na siya ang atong Pascal's triangle. Row number n contains the numbers n taken r at a time. For r is equal to 0, 1, 2, up to n. It is constructed by first placing ones in the outermost positions, and then filling each inner position with the sum of the numbers directly above. This method allows the quick calculation of binomial coefficients without the need for fractions or multiplications. For instance, by looking at row number 5 of the triangle, one can quickly read off that sa row number 5, kani row number 5. Kana, kita ninyo. 1, 5, 10, 10, 5, 1. A plus B quantity to the power of 5 is equal to the coefficient 1 times A to the power of 5 plus 5 times A to the power of 4 times B plus 10 times 8 cubed B squared plus 10 A squared B cubed plus 5 A B to the power of 4 plus 1 B to the power of 5. Okay, so ang kana siyang mga numerical coefficient, mo na siya ang gamit pag-expand ani nga binomial. So, we have A plus B to the power of 5. Kung i-expand na to na siya, ang iyang mga numerical coefficients, mao ni sila. Kaning nasa tong Pascal's triangle. Okay, so if you can try that, A plus B times A plus B times A plus B times A plus B times A plus B. So, i-times nimo siya kalima siyang self, no? Ang resulta, mao ni siya. Okay, example. Let n is equal to 3. Then, n factorial is equal to 3 factorial, which is equal to 3 times 2 times 1. And that is equal to 6. Also, if n is equal to 5, then n factorial is equal to 5 factorial. And that is 5 times 4 times 3 times 2 times 1, which is equal to 120. So, sa ato ang n factorial, kung moingon ta nag 3 factorial, so that is 3 times 2 times 1. Kung moingon tag 5 factorial, that is 5 times 4 times 3 times 2 times 1. Kung moingon ta og 7 factorial, sugod po to sa 7 times 6 times 5 times 4 times 3 times 2 times 1. So, ana lang ang atong factorial. Multiply to tanan n times n minus 1 times n minus 2. So, example, kung ang n na to is 5, kani 5, then ang ato ang n minus 1, of course, is 4. Then, n minus 2, so 5 minus 2, that is 3. N minus 3, that is 2. N minus 4, that is 1. So, mo na ang ato ang n factorial. N times n minus 1 times n minus 2 times n minus 3. Hantod sa 1 na lang dayon. So, ana na siya. For any non-negative integers n and r, where n is greater than or equal to r, the binomial coefficient denoted by n taken r at a time, read as n taken r at a time, is defined as n taken r at a time is equal to n factorial over r factorial times n minus r factorial. So that is equal to n times n minus 1 times n minus 2 up to n minus r plus 1. So that is your n factorial over 1 times 2 times 3 up to r. And which is also equal to n times n minus 1 times n minus 2 up to n minus r plus 1 times n minus r times n minus r minus 1 up to 3 times 2 times 1 all over 1 times 2 times 3 up to r times n minus r times n minus r minus 1 up to 3 times 2 times 1. So, mao na siya ang ato ang pag-solve ang ato ang binomial coefficient, which is n taken r at a time. let us have the remark. N taken r at a time is equal to n factorial over r factorial multiplied to n minus r factorial, which is equal to n taken n minus r at a time. Second, n taken 0 at a time is equal to n factorial over 0 factorial times n factorial, which is equal to 1. Diba? Kaya 0 factorial is 1. And n factorial over n factorial is 1. So that is 1. Which is also equal to n taken n at a time. And the last, n taken 1 at a time is equal to n factorial over 1 factorial times n minus 1 quantity factorial. That is equal to n times n minus 1 factorial all over 1 times n minus 1 factorial. So, kanang diya ma-cancel, ma-1 man na sila. So, ang nabilin is n over 1 or n. So, which is also equal to n taken n minus 1 at a time. So, anyways, para masabtan nato judog maayo, let us have the following example. Simplify the following. So, number 1. Kung given nato 20 taken 17 at a time, that is equal to, so from our formula of n taken r at a time sa itong binomial coefficient, that is equal to 20 factorial over 17 factorial times 20 minus 17 factorial. Diba? Kung n taken r at a time ta, n factorial over r factorial times n minus r factorial. So, mga na siya. Okay, so simplifying 20 factorial na all over 17 factorial, then 20 minus 17 is 3 factorial. And that is equal to, so kung 20 factorial, that is 20 times 19 times 18 times 17 factorial. But ang 17 factorial, that means nga 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 up to times 1. All over 17 factorial times 3 factorial is 3 times 2 times 1. So, atuan lang siyang gikutob 17 factorial since pwede nato ni siya makancel ang sa ubos kay 17 factorial man po ni. So, kana makancel siya. So, what is left on the numerator is 20 times 19 times 18. Yan sa atong denominator is 3 times 2 times 1. Okay? So, kung ato pa na siyang i-simplify further, ang mo resulta, that is 10 times 19 times 6. Yan naman. Ang 20 can be divided by 2. And that is 10. 19 is a prime number, so din mo siya ma-divide. 1 ra jud siya, so 19. Then 18 can be divided by 3, which is 6. So, 10 times 19 times 6 is equal to 1,140. Example number 2. 10 taken 0 at a time. Again, that is n factorial over r factorial times n minus r factorial. So, our n here is 10. So, that is 10 factorial over r is 0. 0 factorial times n minus r. So, 10 minus 0 is 10 factorial. So, ang atong 10 factorial, pwede na ito makansilan. That is 1. And 0 factorial is 1. So, that is equal to 1. Which is equal to, sa ito ang remark, basta 1, that is 10 taken 10 at a time. Next, number 3 example. We have here 15 taken 1 at a time. So, our n is 15, our r is 1. So, 15 factorial over 1 factorial times 14 factorial. 14 gikan sa n minus r, diba? Okay, so, ang atoang 15 factorial can be 15 times 14 factorial. Anong inanion na to? Kaya aron makancel na to ang 14 factorial. 14 factorial over 14 factorial is 1. So, what is left is 15 over 1, which is 15. And that means n is 15, r is 14. So, 15 taken 14 at a time. And the last example, 12 taken 2 at a time. Okay, 12 is n, and our r is 2. So, 12 factorial over 2 factorial times 12 minus 2 is 10 factorial. So, we have 10 factorial man. So, dapat inanin na to si 12 factorial. 12 times 11 times 10 factorial. Para makancel na to ang 10 factorial. So, unsa man na nabilin? 12 times 11 sa ibabaw, 2 times 1 sa ubos. And 12 divide 2 can be 6. 11 divide 1 is 11. So, 6 times 11 is 66. And that is also equal to 12 taken 10 at a time. So, mga to sila itong examples in solving the binomial coefficient. So, sa number 1, mga to siya ang atong gisunod nga formula, which is this one. And then, ang ato ang number 2 is from our remark number 2 pod. And ang ato ang number 3 example, 15 ng n, ang resulta pod is n. That is from our remark number 3. Mani siya. And then, ang ato ang last example, ang mo resulta is 12 minus 2. Ang r diri, 12 taken r at a time. So, that is our example or the application of our remark number 1. Okay, so, mana siya ang ato ang pag-solve sa binomial coefficient. Okay, now let us use our binomial theorem in solving the following examples. Number 1, find the binomial expansion of 2x plus 3y quantity to the power of 4 and simplify. Okay, saan man nato ni pag-expand? Using binomial expansion. Okay, atong gamiton to ato ang binomial theorem. So, atong binomial theorem, kani siya. We will use this formula. Okay, so, we have here 2x plus 3y quantity to the power of 4, which is equal to, okay, ang atong first term, 2x to the power of 4. Ano siya, no? N taken 0 at a time. So, that is a to the power of n na hapon. And then, plus 4 taken 1 at a time. Ang n na to is 4, diba? Then, sunod, diri 2 na pod ang ato ang taken 2 at a time. Diri sunod, taken 3 at a time. Since ang ato ang formula, naman pod. Una 0, 1, 2, 3, 4, and so on. So, na siya. So, here, 4 taken 1 at a time times 2x quantity to the power of 3. Anong 3 naman na? Then, times 3y. Since ato ang formula, n minus 1, then ang ato ang b. So, here po, n minus 1 is 3. Mao na 3 ang atong power ni 2x. Then, RB is 3y. Plus 4 taken 2 at a time. Dayon times 2x squared. Nganong squared naman lang na. Then, we have 3y squared po. Because, ang tatman to'y sunod. A to the power of n minus 2, then u squared po na natong b. So, mo na siya. Then, plus 4 taken 3 at a time. 2x times 3y cubed plus ang 4 to the power of 4 po ni 3y. So, ana ang trend sa ato ang pag-expand sa atong binomial. Then, let us simplify. 2 to the power of 4 is 16. X to the power of 4. Since 2 to the power of 4 is 2 times 2 times 2 times 2, na 16. Plus, 4 taken 1 at a time is 4. Anong 4 man? Diba 4 taken 1 at a time is 4 factorial over 1 factorial times 4 minus 1 factorial. So, 4 factorial over 3 factorial. So, unsa man ang ato ang mahabilin? So, 4 na lang, diba? Okay, so 2 cubed po is 8x cubed times 3y. Plus, 4 taken 2 at a time. Unsa man eh? This is 4 factorial over 2 factorial times 4 minus 2 factorial. So, 4 factorial over 2 factorial is 2 times 2 factorial. So, 4 ang ato ang denominator. So, ang ato ang resulta, 3 times 2 times 1 na lang ang bilin. So, mooning 6. Dayon times 2 squared, that is 4x squared, times 3 squared is 9y squared, plus, kanipod, 4 taken 3 at a time. This is 4 factorial over 3 factorial times 4 minus 3 factorial. So, kung naatay 4 factorial, makancel ang 3 factorial sa ubos. So, ang nabilin is 4 sa ibabaw over ang ato ang 1. So, ang nabilin is 4. 4 over 1. So, morning 4 ni siya dere. Again, mao ni atong gisolve nga kuan binomial coefficient kaniha. Using this formula. Kani. Ang kanatang gigamit ha. Okay, balik ta dere. So, 2x, copy, then 3 cube is 27, then y cube. Plus, 3 to the power 4 is 81. Y to the power of 4. So, simplify na po na to, combining like terms kung naa. Okay, 16x to the power of 4 plus 8 times 4 times 3 is 96 x cubed y plus 6 times 4 times 9 is 216 x squared y squared. Kana. Plus 216 x y cubed. Since 4 times 2 times 27 is 216 x y cubed. Plus 81 y to the power of 4. Okay, so mo na siya ang atong pag-apply sa atong binomial theorem. Given this example. Okay, second example. In the expansion of 2x squared minus y cubed quantity to the power of 8, find the fourth term and the middle term. Okay, so this time, given this, pangitaon na to ang fourth term ug middle term lang. Okay, solution. Using the binomial theorem so we use the binomial theorem in expanding this one. Okay, A nato is 2x squared. Kani siya, kaning first na term sa atong binomial. And then, b is equal to negative y cube. Kani siya, negative y cube. Then, n is equal to 8. Kani ito ang exponent. And r plus 1 is equal to 4. Since fourth term na itong gipangita, then, ang atong fourth term is r plus 1 is equal to 4. And that is equal to 3. So, ang r nato is 3. Okay, mo na siya ang atong fourth term. Diba? We have this 8 taken 3 at a time. Kaya ang first term katumang 0 ang r. Second term ang 1. Third term ang 2. So, ika-fourth term ning 3. 8 taken 3 at a time. Okay, then, let us move to 2x squared to the power of 5. Multiply na to siya. Asa man na siya gikan? Dito na sa ato ang binomial theorem. 8 minus 3, diba? A to the power of 8 minus 3. Okay? Ika-fourth man ta dito. Fourth term kani ang first term, second term, third term. Ang ika-fourth term n minus 3 nasa ibabaw. So, mao ni siya nga 5 ni siya. To the power of 5. Then we have negative y cubed to the power of 3. To the power of 3 po ta diri kay ang third term ni. Ang fourth term kay b cube man. So, mao ni nga okay. Negative y cubed to the power of 3 ta. And that is equal to 8 taken 3 at a time. That is 8 factorial over 3 factorial times 5 factorial. 5 is 8 minus 3, diba? 5 factorial na. Then we have 2 to the power of 5 is 32. X to the power of 2 times 5, that is 10. Then times negative y to the power of, kani 3 times 3, mga na siya 9. And that is equal to, so, ato ang i-simplify further. Since natay negative, maaning negative siya. 8 factorial over 3 factorial times 5 factorial. That is equal to 1,792. Then x to the power of 10, y to the power of 9. Okay, next, ang atong middle term na po atong kuhaon. The expansion has 9 terms. So, the middle term is the fifth term. Natay 9 terms, diba? Since 8 man ang atong n, then we have 0 sa una, diba? So, mao na 9 tanan ang atong term. So, ang middle sa 9 is the fifth term. Since middle term man atong kaon. So, let us get the fifth term. Hence, r plus 1 is equal to 5. So, r is equal to 4. Ang r is equal to 4 mo na siyang ika-fifth term. So, 8 taken 4 at a time. 2x squared, quantity to the power of 4. Since 8 minus 4 is 4, mo na siya. Then, negative y cubed to the power of 4. Since mo na siyang ato ang fifth term, 4 diha ang power. And that is equal to, okay, haman ta gikan og 70. Ang atong 70 gikan sa 8 factorial over 4 factorial times 8 minus 4 factorial. So, mo na natin 70. Then, 2 to the power of 4, mo nang 16. X to the power of 2, then times of 4. Mo nang x to the power of 8. Then, y to the power of 3 times 4, that is 12. Since even man ang atong power diri 4, ma-positive ni siya. So, mo nang positive ni siya. Okay, then 70 times 16, that is 1,120. Then x to the power of 8, y to the power of 12. Okay, last example. Find the term involving x to the power of 8 in the expansion of y plus 3x squared quantity to the power of 6. Okay, ang term na to, kanang nag-involve og x to the power of 8. Solution. The r plus 1 to the power of nth term in the expansion with a is equal to y. So, ang atong a is y. B is equal to 3x squared, kani. And then is equal to 6 is, okay, 6 taken r at a time. Y to the power of x minus r. Kana siya. Times 3x squared to the power of r. Which is equal to x taken r at a time. Y to the power of 6 minus r. Then, distribute na to ang r dere. So, 3 to the power of r times x to the power of 2r. Since we are looking for the term that involves x to the power of 8, we have 2r that is equal to 8. Okay, since ang ato ang gipangita ang nag-involve og x to the power of 8. Okay. So, ang ato ang x kaniman. Dapat 8 ang ato ang exponent. So, ang atong r is 4 since 2 times 4 is 8. Ang r is 4. Hence, r plus 1 is equal to 5. Okay? Kay 4 man ang atong r, so r plus 1 is 5. And the fifth term is, so, mani siya ang atong fifth term. 6 taken 4 at a time. Y squared, 3 to the power of 4 times x to the power of 8. Mani siya ang nag-involve og x to the power of 8, diba? So, gikan na siya diri. Since ato na ibawaan nga ang r kay 4 man, so gi-apply na to ang 4 diha. So, y to the power of 6 minus 4 mo aning 2. Then, 3 to the power of r nga mo na 4. Then, x to the power of 8. So, ang ato ang 6 taken for the time, that is 6 factorial over 4 factorial times 2 factorial, which is equal to 15. Then, y squared, and 3 to the power of 4 is 81. X to the power of 8. 15 times 81, that is 1,215. Y squared, x to the power of 8. Okay, so mo na siya ato ang binomial theorem. And saan na to siya pag-apply in solving. Thank you.